Well, the students who are on YouTube, you should have been seeing me a long time ago. And then the others on TikTok should just be seeing me. The bird feed. Great. Good evening. Now, just excuse me for a second, I'm going to be looking over here. Right. So, good evening, one and all. Welcome. Thank you for joining. Thank you for the support. Some people say that I'm a genius. Some people say that I have ambition. Some people say that I have good intentions for others. But believe me, no matter how much of a genius I am, no matter how much good at intention I have for others, and no matter how good a person I am, it does not matter, and it will not matter unless you join. You join, you invite others to join, you share the word, you spread the word, you share the life, and there are some other things that you do that I don't even know the meaning of. And as I used to say, a man finds time for the things that he is interested in. So the thing that I'm most interested in is to ensure that you learn something when you come inside here in the evenings. I'm going to get a lot of beating this evening, but I'm prepared. Because this class is especially for students who are doing the examination in January. So the students who are doing the examination in January, you are the ones who I'm crazy about in this one. And the ones who are not going to be doing the examination in January, just treat this as another class that you go inside and you relax and you try to get as much as you can, and you can afford to take a second look at it. Because for you, it is not my intention to turn my head around in order to satisfy your every wish. I'm not going to be at your whims and fancies. The Tuesday class, the modules that we are doing in Tuesday class, this is the one that we are working on today. We will do these again in January. Functions part 1, functions part 2, vectors, matrices, and transformation. Those are the modules for Tuesday class. Tuesday class, I expect it to be the least populated, while at the same time all are invited, because every one of you will learn something. So going into January, you would have learned the entire module already, or even 1/3 of it, if not 1/4 of it is good. Right? So, for me, this module might be over the head of some of the students who are here, but it will be taught again. And I cannot afford to disenfranchise students who will be doing the examination in January. I have to ensure that they get their fair square of the deal, because those students who are doing the examination in May, you will have all the time in the world to take a second look at this in January. January, February, and March. Hopefully it does not get to the end of March. So, thank you all for joining this live. Thank you. And I hope that you enjoy. I'm looking around. All I'm looking around for is a box of marker. I think I'll find that box of marker in a minute. But of course, as you would imagine, I have markers and more markers, and more and more and more markers, and my markers will not be finished. When I have markers at the beginning of the school year, they last until June. Believe me, I have to buy another marker. Okay, so let's go. We started this module last week, and we are going through some function stuff. And this evening, I'm not going to slow down for the students who are doing the examination in May, because we are going to teach this again. So the next thing that we're going to be looking at is composition of functions. Composition of functions. What do we mean when we say composition of functions? What do we mean? Of course, there we have it, yes. Yes, we have composition of functions. What do we mean by composition of functions? Last week, we saw a function, say h of x. We saw h of x is equal to x squared, something like this, plus 4x. I don't even remember if it's minus. Plus 4. We had a function like that. And then we wanted to find h of 5. So we say h, that's going to be a large number. H of 5. And it's going to be a square number, I know. It's going to be 5 squared plus 4 5s plus 4. Why? Because all that we have done is replace the x with the 5 here Therefore, we replace the x with the 5 in the expression. So we have x squared, 5 squared. 4x, 5, 4x, 4 times 5. And then we have 4 returning like that. So this turns out to be 25 plus 20 plus 4, which is equal to 49. Of course, I said it would be a square number. I'm right. It's going to be the square of 7. So what we did last class is that we caused a function to operate on a number. And what does this function achieve? If you have a set over here with 5x, so the function maps this over to x squared plus 4x plus 4. So any number that you have over there, you put it inside the function. This one will give you 49. So 5 will map over to 49. That's what it means. But now, this afternoon's class, evening's class, is a little bit more sophisticated than that. We are not only causing h to operate on a number, or a function to operate on a number, we are causing a function to operate on another function. So for the composition of functions, we have what? A function operating on another function. And the result is another function. Instead of a pure number like this, when a function operates on another function, what we achieve is a function. And that function is called a composite function. So let me just put a statement here. The composition of functions f and g is denoted by, this is the ancient way, a little o right there, or a little circle, f of g. Yes, it's called f of g. What do we know about f of g? And I'm not going to say it. We're going to write it in another way. And they write it without this. They might write it as f of g. They might do it like this. Or just fg. Like that. So there are quite a few ways to express the composition of functions f. The composition of functions f and g. I'm going to put it down here. Right. So the composition of functions f and g is denoted by this one, f of g, or f of g of x, or f of g. And it is the function that results when f operates on g. Right, so f operates on g, that is what we get. Now, what we will do, the resulting function is called composite function. The resulting function is called a composite function. So the composition of functions f and g is denoted by this one, or this one, and is the function that results when f operates on g. And the resulting function is called a composite function. There's nothing special about it though. It's only called a composite function because it's the function that results when one function operates on another. There's nothing special. You look at it, it doesn't look special. It doesn't look weird. It does not look like you can tell that it's a composite function without somebody telling you. You should not be able to tell. So you should not be able to tell that it's a composite function unless you actually produce that function or somebody else tell you. It doesn't look different. Now, we are going to put functions there on the board and we will do the composition of functions. Right, as I said before, I am not going to tailor this for students who are doing the examination in May. I'm going to tailor this class for students who are doing the examination in January. So, that does not mean that you cannot ask questions. But I will let you know the ones that I will forfeit. Feel free. Alright? Feel free. Alright. So, let's go. I'm going to put the functions here. I'm going to erase there because I'm going to start breaking the functions out there. So, f of x is your old f of x function, which is what? 2x minus 3. 2x minus 3. H of x, because these two functions are flat, they are polynomials. X squared plus 4x, I think. Is it different? No, it's the same. Plus 4. And I'm going to write g of x up here because g of x is hilly, is x plus 1 over 3. X plus 1 over 3. This, students, it is very important for you to attend as many classes as possible and also to be prepared to bring over knowledge. And you will see what I mean in short order. So the first function that we will find is f of g. F is operating on g. F is operating on g. Let's go. Number 1, f of g is equal to, now students, the knowledge is power. Is it clear? Is poder? Knowledge is power. I'm going to give you a bit of knowledge. When students are asked to compose functions in an examination, the most popular mistakes that the students make is that they put the wrong function into the other. So if they are required to find f of g, they should put g into f. Instead they put f into g. They say f of g, oh, f into g. And of course, you know that for every single common mistake that students make, I have something to say about it. If not, to outright give you a code to avoid it. An error correcting, error detecting code. That glare that I see on the board, I tried to eliminate it just now. And it's things running around on the board. Anyway, let's see. Yes, there's a glare right here. Is there? No, it's there. If I go here, I see. All right, so let's continue. So f of g, this is how you avoid making that mistake. So this is how you avoid making that mistake. F of g, look at this. You take it from right here. Remember, f of x is 2x minus 3. F of 5 equals 2 5s minus 3. F of 0 is 2 0 minus 3. F of triangle is equal to 2 triangle minus 3. So f of g now must be 2g minus 3. So you start it off like that. Two g minus 3. Because f is operating on g in much the same way that f is operating on any number. Now, where the mistake stems from is that students begin with the algebraic representation of the function. So, you begin by saying f of g. You don't say 2g, you say 2 and you put in the expression for g. And sometimes you say, put in the expression for f when you're making the mistake. So students are sometimes too hasty to put the algebraic representation inside there. So I strongly suggest, because I don't dictate mathematics to students, I'm always demonstrating to you a very useful way, a safe way, and saying that you can avoid such and such by doing this. But I'm not saying that you must do this or you must do that. But that is the safest way. After doing that, then you put the algebraic expression inside there. You know what that does? Just by doing this, you know what it does? By doing it this way? Even before you start to compose the function, you get at least a mark or half of a mark already. So you have mark guaranteed because you have demonstrated what you have demonstrated that you know what it means to compose function f of g. Because right there, you're putting g in the expression for f. Just like how you write f of x is equal to 2x minus 3. The examiner sees that, and the examiner is sure that you are sure. And you start to accumulate marks before you start to solve the problem. Then, what happens next? You put the expression for g there, and g is x plus 1 over 3. X plus 1 over 3. And then you minus 3. So we have 2g minus 3. 2, this is g as you can see right over there, minus 3. Let me write the minus 3 a little bit better. Minus 3. Use a tactic that you learned yesterday. So let's begin. This is equal to 2x plus 2 over 3. Oh, Mr. James, you did not multiply the denominator. Yes, I did. Because some students make a mistake when they are multiplying a fraction by a number like 2 times this. They multiply both numerator and denominator by the 2. But we learn from tutorial that when you multiply the numerator and denominator of a fraction by a certain number, it does not change the value of the fraction. But you are saying that if we are multiplying the fraction, we need to multiply both numerator and denominator. For sure, we need. So we have to consider also that 2 is a fraction. So that's what you do. If you are multiplying a number like this by a fraction, you have to consider that 2 is a fraction also. And of course, 2 is a fraction is what? 2 over 1. So the numerator, which is 2, multiplies the numerator, and the denominator, which is 2 over 1. So the denominator is 1. It multiplies the denominator. And those who were in tutorial Sunday, you know this one. 9 over 3. Because this is a negative 3 that you have right here. And you're writing it as 9 over 3. Because negative 3 is negative 9 over 3. Because 9 divided by 3 is 3. So this is equal to that. It's the same thing. But why? Because we want the denominators to be the same. So the addition or subtraction may be simple. Because when you're adding fractions with the same denominator, then you just add the numerator and put the answer over the denominator, which is a common denominator, because the denominator is common already. So what do we have? F of g of x is equal to 2x. We're going to have a plus 2 minus 7. Your directed numbers are haunting you already if you neglected them, or you did not take them as seriously as I said or suggested. So what do we say? 2 minus 9. 2 minus 9 is equal to, all my directed numbers, kings and queens. 2 minus 9, what is that equal to? I'll soon look at the screen for the results. I'm looking at the next one. No answer? Since no one will answer, I've not seen the answer over here as yet. All right, well, I'll continue. No one can say 2 minus 9 is equal to, nice, negative 7. So that is f of g of x, which is your first composite function. Let's continue. 2 f of h. I like that because it's flat. F of h. F operating on h. What do we say for f operating on h? Since f operating on x is 2x minus 3, then f operating on h will be 2h minus 3. 2h minus 3. And then what do we do after that? We put there the algebraic expression for h. What's the algebraic expression for h? X squared plus 4x plus 4. x squared plus 4x plus 4. And then it should be what? 2h minus 3. 2h minus 3. And you know that I'm not going to take another 2 steps. So f of h of x, what's that equal to? 2x squared when I multiply this plus 8x when I multiply this plus, I will not write that. We are going to work it out. 2 times 4, that's 8. So 2 times 4, that will be 8, minus 3, so that's 5. I'm not going to write an entire line just to say 8 minus 3 equals 5. So that is your second. And we'll move merrily to number 3, which is g of h. Number 3 is g of h. G of h. So g will be operating on h. G will be operating on h. So what do we say when g operates on h? G of x is x plus 1 over 3. So g of h is h plus 1 over 3. Come on, that's straightforward. G of x, x plus 1 over 3. G of h must be h plus 1 over 3. Nice. H plus 1 over 3. So what do we say? This is equal to, what is h? H is x squared plus 4x plus 4. I'm going to do it in 2 steps. Shouldn't do it, but over 3. That means g of h, turns out to be what? I'm going to write it for the final step. G of h of x. Somebody said this don't look like an x. What do we write as? It's simply x squared plus 4x plus 5. You can see the 5 right there. All over 3. Very nice. Nice. So I'm going to take a look at number 4. G of f. Well, we imagine that G of f will be just nice and neat. But let's see G of f. So G of f, what would that be equal to? G of x is x plus 1 over 3. So G of f will be f plus 1 over 3. F plus 1 over 3. Nice. Which is equal to 2x minus 3 plus 1 over 3. And we are finished. So G of f of x will be equal to 2x. I'm going to ask my directed numbers, kings and queens, what is negative 3 plus 1? What is negative 3 plus 1? I'm checking right there. I've not seen the answers yet. And I'm going to check on YouTube to see what they will say. Any answers yet? No one is ready to say what negative 3 plus 1 is equal to? I'm wondering if okay, yes, I see my sound graph, so I know that you're hearing me. Thank you very much. So 2x minus 2 over 3. Beautiful. Now here is the danger. And for this one, I will not spend the entire evening explaining it. Yes, we have another person supplying the answer. That's very nice. So we are on top of our games again. Your favorite now. I'm sure it's h of f. H of f. What's that equal to? That's nice, man. Number 3. This one is number 4. And then this one is number 5. H of f. What is h of f equal to? H of x is equal to x squared plus 4x plus 4. So h of f will be equal to f squared plus 4f plus 4. So if we put that inside here, where we see f, we put the expression for f now, we're going to have what? F squared 2x minus 3 all squared plus 4 times 2x minus 3 plus 4. And that is equal to, students, I'm going to write it down in one step. Functions part 1. Which book am I working from? Functions part 1. So the person who is asking me which book I'm working from, are you doing the examination in January? Thank you very much. He's working from Functions Part 1, Volume 2. Right, so the book is Volume 2 and it is Functions Part 1. That's 100% correct. Oh, that's nice. Okay. Now students, this one, I will not spend the entire time to explain it because it is going to be explained in algebra to the fullest, and it's going to be explained in the same Functions Part 2 book in January. But if I spend the entire time to explain it in detail, the students who are doing the examination in January will be shortchanged, and that's what I do not want. Let's go. 2x minus 3 all squared, what is that equal to? Square 2x, square 2, I get 4. Square x, I get x squared. I do not just square 3 to get 9. There's a middle term that's equal to 2 times the first times the second. So multiply 2 times the first times the second. 2 times 2, 4, so that's 4x. Times negative 3, so we're going to have a negative 12x right there. And of course, you know that when we square a negative 3, we get a positive 9. Fine. And then what do we say next? Plus, and we're going to expand this. 4 times 2x is 8x minus 12. And we're going to have a plus 4 at the end. So we're going to finish up right here. It's h of f. H of f of x is equal to, the 4x squared will go back. Then the x's will be a negative 12 plus 8. What is a negative 12? A negative 12 plus 8. What's the answer for that? Negative 12 plus 8. Thank you very much. That's a negative 4. So we're going to have negative 4x. I'm going to write it somewhere where it can be written wide on the board. F of h of x is equal to 4x squared minus 4x. So it's 4x squared minus 4x. And of course, everything else is positive. 9 plus 13. So we have a 9 here and the 4. So 9 plus 4 is 13. Now, the results are noteworthy. We have f of g that I'm going to mark with an asterisk here. And I'm going to mark g of f. If I can find it, yes. I'm going to mark g of f also with an asterisk. I'm going to mark f of h with a spiral, and I'm going to mark h of f with a spiral. What do you notice about the pairs that we mark? What do you know about f of g? You see f of g here, f of g is 2x minus 7 over 3. Then g of f is what? G of f is 2x minus 2 over 3. F of g, 2x minus 7 over 3. G of f, 2x minus 2 over 3. Is that like what you expected? Or it's like, no, I didn't expect that? Let me get a yes or a no. Did you expect f of g of x to be something like 2x minus 7 over 3? And then g of f to be 2x minus 2 over 3? Yes or no? Yes or no? No, yes. What do you say? Anyone wants to say something? Give you a few seconds. If when I return no one has anything to say, then I will have no feedback, and then the class will not be as beneficial to you as it really should. But it will be of benefit nonetheless. So you do not have to worry. So f of g is 2x minus 7 over 3 and g of f is 2x minus 2 over 3. Is it in any way like what you expected? Yes or no? No one with an answer? When I did, yes, when I did composition of functions for the first time, there was something that I noticed. And what I noticed was different from what I expected. I noticed that f of g is not always equal to g of f. Because I think that when you switch them around, you should get the same result, pretty much. Just off the top of my head without giving it serious consideration. Why? Because I would have been familiar with multiplication. And when I multiply 2 times 7, I get the same thing as 7 times 2. And in addition, the same thing. 2 plus 7, I'll get the same thing as 7 plus 2. And it is true in every single case that I add. And it is true in every single case that I multiply. Thank you for your beautiful rose. Right, so I expected when I compose the functions, then compose them in the reverse order, that it would be the same. Of course, on second thought, they don't look the same. But that's what I expected at first. Not that I was like surprised out of my wits, because I was prepared to do a little bit of investigation, which you should be prepared to do also. What do I erase? Maybe there's only one that I can erase. Yes, I think that there is only one. But I think that I can erase the others and leave the G of F. Yeah, because I don't think I need more than a single pair to tell. No students. No students. When we compose the function f of g, we get this. When we compose the function g of f, we get this. So when we reverse the order, the composite function is different. So what do we say? We say is f of g is not equal to g of f for every or for all This means for every or for all. The V with the slash through it, that one means for every or for all. So the composition of functions is not commutative. That is, f of g is not equal to g of f for every functions f and g. It should be for every or for all. So it can be read for all functions f and g. Or we can write it for every function, then we would have to take the s off. For every function f and g. So you could put an s or you may not put it, because this might be read for every or for all. Now, let me just take a second look at this. What does it mean? For an operation to be commutative, it has to work back and forth, because that's what to commute means, to go back and forth. It needs to work back and forth for every single case. It has to be true in every single case. So if you can show one case in which it does not work, then the operation is not commutative. For it to be commutative, it has to work for every single case. So, take a few seconds and we are going to be taking a look. Of course, students, it is important to note that the composition of functions is not commutative, as it is important to say that the multiplication of matrices is not commutative, because it has serious implications. This has serious implications when you are going to be manipulating functions in a few minutes. So, just a minute and a half or two for you to take a look at what we have here, a second look at it, and then we will look at the inverse of a function. Beautiful. So we're going to be taking a look now at the inverse of functions. Every time I step aside, they want me to fit in stuff just to go back on this TikTok. Then don't give me another one and say fit this in. Let's continue. We're going to be looking at the inverse of a function. The inverse of a function is its complete reverse. And let's see if anyone can do the inverse of a function practically in real life. Let's see who is prepared to do it. The inverse of a function. Let's see who is prepared to do that in real life. The inverse of a function is its complete reverse. So let us look at a function. This one, f of x. This marker right smoother than the next one, let me tell you. F of x is equal to this. I don't want to give you any joke about this marker, you know. It's just that I'm afraid of it. 5x plus 8 over 6, 7, 3, 2, 5, 4, 2. So that is your function. 5x plus 8 over 2. That is your function. Now, your function, as you can see, and you know that a function of x is operating on x. So x is your target. So you're targeting x. How? Notice that something is happening to x. So what I do is they multiply x by 5. Then they add 8 to the result. Then they divide the result by 2. So they have done 3 things to the function. Right? They have done 3 things to the function. Not to the function. The function is doing 3 things with x. So we have what? Step 1. Then we have what? Step 2. Then we have what? Step 3. This is your beginning. And this is your end. So you start here and you end here. And in order to do that, you would have taken 1, 2, 3 steps. Now, the inverse of the function is a complete reverse of the function. You know what that means? That means if you are here, what would you do in order to go back there? Any suggestion? If you are here, what would you do in order to go back there? Please let me have your suggestion. I'll be delighted to hear what they are. I see a lot of things scrolling up on the screen, and I was hurrying to take a look at your response. If you are here, any answer, what would you do if you are at the end and you need to go to the beginning? That is what practically finding the inverse of a function is. I asked a question. Do we have anybody in the classroom who is doing the examination in January? Just waiting for an answer. Not only the answer for if anyone doing the examination in January. I am also, yes. Yeah. That's beautiful. So we have, yes sir, sure. We have students doing the examination in January. If you want to say something, then you can, like if you can request to, oh that's nice. All right, yes. So I'm also waiting now for the answer. If you are at the end now, given this process, if you are at the end, how will you get to the beginning? I'm not going to wait for too much longer. Every day there's something come up and start to give me trouble. I'm going to get rid of it. Now, what will we do? We need to reverse the entire process. We need to reverse what? The entire process. How do we reverse the entire process? We will reverse the entire process by doing so step by step. Just like how the process consists of 1, 2, 3 steps. In going back, we need to go 1, 2, 3 steps. But if we are here, what do we do? Before we do that, we'll write down the 3 steps of this function. So 5x plus 8 over 2. What is the first thing that we do to x? So let me write it down here. 1. F of x is equal to 5x plus 8 over 2. What is the first thing that we do to x? Anyone can tell? The first thing that we do to x? Yeah, multiply by 5. Beautiful. What's the next step? Number 2. Step number 2. Then we do what for step number 2? Then add 8. Yeah. And then what do we do for step number 3? I'm going very quickly because I intended to see going on the screen very quickly. Then divide by 2. Divide by 2. Nice. Now, if we are going back to the beginning, what do you think that we should do first? Or what is the new process? All right, let me ask you, what is the new process? F inverse of x. So we're going to do, what are we going to do for the first part? What will we do for the first part? Multiply by 2. Student, this is not love. This is mathematics. I really needed a reason for the things that I do. But your answers are perfect so far. So we multiply by 2. Multiply by 2. And someone say that we should. I'm going to catch it before it scrolls. Subtract 8. And the next one, I'm going to try to catch it before it goes off the screen. I haven't seen it as yet. Divide by 5. Why? Students, if we are going to go back from here to there, the first step that we need to reverse is step 3. Then we reverse step 2. Then we reverse step 1. We reverse the last step first. And we reverse the first step last. So what that means is that we are performing the reverse of the steps, and we are performing them in the reverse order. Yes, so we are performing the steps, and we are performing them in the reverse order. Therefore, this function that we have here, which is what? F inverse of x. What do we say about it? F inverse of x is equal to multiply by 2. Do not forget that the function is operating on x. So if we say multiply by 2, it means that we are multiplying x by 2, which gives us 2x. So 2x multiplied by 2, subtract 8, then divide by 5. And that's your function. And I'm delighted to see the younger students inside here throwing in their weight also, because we are not going to wait for the entire 5 years if we have the opportunity to learn now. The Chinese not doing it. The Japanese not doing it. The white man not doing it. The Indian not doing it. It's only in our race that we say the child is too young to do this, too young to do that, too young to do everything that is good, but not too young to do anything that is bad. Do not forget, students, this name. Let us see if I can remember his name. Winston Chu. When Winston Chu was 12 years old, he got 1 for mathematics, 1 for English, 1 for Spanish, and 2 for French. When he was 12 years old, he got 1 for mathematics, 1 for English, 1 for Spanish, and 2 for French, when he was only 12 years old. Now, students, do not forget this. that when you're finding the inverse of a function, what do? You reverse the steps of the function, reverse the steps that are contained in the function, and you perform them in the reverse order. So the function say I do step 1, I do step 2, and I do step 3. The inverse of the function says I reverse step 3, then I reverse step 2, then I reverse step 1. Now, with that consideration, I need you to do this exercise, if I can find it. Theory, what do I say? I have to say something. Inverse of a function, yes. Exercise 1F, and it's on page 7. Exercise 1F, and it is on page 7. After you have done that, then we'll take a look at something else. How many parts do you have? I have 7 parts. All right. Begin. I know that some students will have started already.
Good evening.
Good evening. Now, I do not understand what you mean by what is the reverse step.
Pardon?
Yeah, you said what is the reverse step? So you need to clarify so that I can explain it to you clearer.
I just logged on, so I'm not sure what I am looking at.
Oh, if you just log on, then it's gonna take like another good 15 to 20 minutes for me to explain to get you right here.
Okay.
Are you doing the examination in January?
Pardon me?
Are you doing the examination in January?
No, I haven't started as yet.
Oh, you're not doing the exam in January. All right, you know that we'll take a look at all of these in January again. So those students who are not doing the examination, you are not at a loss. So I'm really accelerating a portion of the course for the students who are doing the exams in January. And the acceleration portion of the course will be on a Tuesday afternoon.
Okay.
All right. So I'm going to explain these.
Thank you.
Yes, you're welcome. I'm going to be explaining these all over again for the students who are not doing the exam in January. But for now, it's the students who are doing the exam in January that I'm taking priority to. Hopefully, if you just remain focused, then you will see, especially if you take a look at the results of the exercise that the students will be doing in a minute, then I'm sure that you will get to understand some of what we have right here.
Noted.
Okay, so even though that you're logging on late, and it will take a lot of explaining, I think that you will be able to follow some of the things that we have here if you pay attention to how the students answer the exercise. Okay?
Okay.
Okay. So, I'm going to take this off. Some students will have finished the exercise already. And we have some students who do not have the book, so f of x is equal to 7x minus 1 over 9. 2, g of x is equal to x plus 2 over 7. X plus 2 over 7. 3, h of x is equal to 8x minus 3. H of x is equal to 8x minus 3. 4, P of x is equal to x plus 5. 5, Q of x is equal to 2x. 6, C of x is equal to x cubed. C of x is equal to x cubed. And the notorious, infamous 7, T of x is equal to 10x plus 19 over 27. All right. So what I will do now, yes, what I will do now is give you a few seconds to just write down the inverse of the function by doing the reverse of each step and performing them in the reverse order. Some of the functions will have 3 steps, some have 2, some have 1. Right. But find the inverse nonetheless. Let's go. Yes, you will know, you will see that, you will recognize that the middle one, all right, of course there's a reason for that, and that is why you have some amount of flexibility, you have to exercise some amount of flexibility with the functions that we have there, because you will not always have a 3-step function. Now if you have a 3-step function, then whether you're going back or forth, the second step will always be the middle step. And that is why its position will not change. But of course, the sign will change because its operation will have to be reversed also. So, because there are 3 of them, the middle one will not change its position. But of course, its operation will have to change. Right, it will change in whether it is positive or negative. And now I've just explained why. Now, what is the next thing? You will see functions there where it's only 2 steps. And so, then that rule will be violated somewhat. Because there's hardly going to be a trapped middle expression, middle process or middle step. Now, I think that you have looked at them for long enough. My next question is, anybody is ready for us to write down the answers on the screen? Let me know. do factorization. Factorization will be done on in this book. It's in this book. The factorization is in this book. Let me put it right here. It's in your algebra book, which is the same book that we'll be using on a Monday. Is it a Monday? A Monday and a Thursday, yes. But for you to get to factorization, you have to do directed numbers, you have to do indices, and you have to do basic algebraic expressions. Because if you jump to factorize and you do not know anything about your positive and negative numbers, you're gonna make a meal of them when you get to the ultimate, which is trinomials. You can't factorize if you can't divide. You can't divide if you don't know indices, and so on. So we have to do those topics before we get there. But when we get there, we're going to have a wonderful time, because you're going to have basic factorization, you're going to have factorization by grouping, you're going to have difference of two squares, you're going to have basic trinomials, then you're going to have large coefficients, and then you have the twisters, and then you have some more. So many things in factorization. Don't be in too much of a hurry. All right, so let's go. Let's write down the inverse of these functions. The process say multiply by 7 minus 1 and then divide by 9. So what do we need to do? I'm going to use the same color. So f inverse of x, what do? We multiply by 7 minus 1 divide by 9. So we are going to multiply by 9, add 1, and then divide by 7. Is that okay? I think that this one is a little bit flatter. Yes, I think that this one is a little bit flatter. If for this one, we add 2 and then divide by 7. We add 2, then divide by 7. What do we do next? What do we do? Add 2 and then divide by 7. I'm going to invite some individuals and see if you can tell me some of them. And see if you can, any one of you willing to come and tell me some of them. Ready? So let's go. What do I say for this one? G inverse. Alright, I'm going to do that one until I get it. So we add 2, then divide by 7. So what will we do then? Multiply by 7, so I'll get 7x, and then subtract 2. Anybody is in and is willing to tell me? Let's go.
Number 3, so yeah, add 3 and then times by 8.
So we should add 3 first. So it's x plus 3, and then what do we do next?
Multiply by 8. Divide by 8.
So what do we need to do now?
Divide by 8,
Yeah, we need to divide by 8. Exactly. one is a single step. So P inverse of X, what's that?
Take away 5.
So X
But,
take away 5. You see how you talk it in the group? You're going to write it the same way in the exam. Now you just need to be forthright. X take away 5. So you just say it explicitly, just as bold as you're going to write it in the examination in order to get your grade. So what do we say about Q inverse of X?
so we can say right from the board and number
We'll
5.
write it here. Q of X is equal to 2X. So what is Q inverse of X?
X divided by 2.
For sure. And not 2 divided by X. It could not be 2 divided by X because we are not operating on 2. We are operating on X. And finally, no, not finally, number 6, C of X is X cubed.
So we have to find cube.
You're going to find the cube root. Right. So if you do the reverse of cubing the expression, you're going to take the cube root of X. And this one is your favorite. Yes. The one with the person who would love to do the one that contains 3. Yes, some of the students enjoy doing the one that contains 3. What is it? T inverse of X. What is that equal to?
So multiply by 27.
So it's 27X
Subtract 19.
subtract 19
Divided by 10.
divided by 10. Yes. So here you go. And there you have a wonderful time. Yes. Beautiful. All right. All right, so what do we do next? Apart from nothing. We will do the inverse of functions by transposition of formulae. So we're going to take this out. And we're going to take this out. I'm going to leave mainly the stuff that we have on the board for a long time. See how some of these markers are difficult to erase? Because they are substandard markers. Let's go. So what do we say now? If we have a function and we want to find its inverse. Yes, if we have a function and we want to find, that's nice. If we have the function and we want to find its inverse, what do we do? We have a function and we want to find its inverse. We can do it algebraically. So we might approach it by making use of algebra. So what do we do? Since the inverse of a function, it's complete reverse, a total turnaround. What do? Where we see f of x, we put x. And where we see x, what do you think that we should put? Because we are turning the thing inside out. We are turning it the other way around. If we have f of x, where we have f of x, we put x. Where we have x, any suggestion? What we are going to put there?
So I'm 100% certain, but
Repeat that.
No 100% certain, but if.
What you mean? When I go in examination, I'm going there 100% certain, The only thing you need to go in there certain about is that any question you see in there, you're going to answer it to the best of your ability. That's the only thing you need to be certain about. Really, if it's a real exam, that is the only thing that you should be certain about. But don't say you're not certain, just answer. So the same person said I should put F there. Alright, that's the best answer I've ever heard since I've been doing mathematics. And you think it's lie? Alright, we don't see why it's not lie. We're going to see why it is not a lie. That's the best answer. Some students say put Y because the teacher said put Y. Yes, so some students say put Y because the teacher said put Y. But you say put F there. Now, if you are going to switch this around completely, then just by looking, surface effect, you are going to put f of x here. So I'm demonstrating why saying f is the best answer. So it's okay, you put f of x there. Or you just say put f without saying put f of x. Just put f then. When at the same time, it makes perfect sense where the f of x goes where the x was and then the x goes where the f of x was and you just put it around like that and that's fine. However, what you are attempting to find is not f, but the inverse. So what this should really be is f inverse of x. So that makes f the best answer because you did not say f of x and you did not say f inverse of x. You just say f. So you are at least sure that is f or some conjugation of f that should be there. So the most appropriate one is f inverse of x. Why is it f inverse of x? Because when you finish, what you find will be the inverse of function. And then now we put that over 2. So our intention is now to solve this equation for f inverse of x or transpose the formula making f inverse of x the subject. So, excellent, right. So what do we need to do now? In making f inverse of x the subject of the formula, what do we need to do first? We want f inverse of x to be the subject of the formula, so we need to eliminate the 5, we need to eliminate the 8, we need to eliminate the 2. Which one do we eliminate first?
Okay.
Multiply by 2. Excellent. So we need to eliminate the 2 first. And we will eliminate the 2 by doing what? Multiplying by 2. So we multiply both sides by 2. When we multiply both sides by 2, the 2 will be eliminated by 2 cancelling 2 here. And then the 2 is going to multiply by the x here. So you get 2x. So 2x is equal to 5 f inverse x plus 8. And what do we eliminate next? If anything, what do we eliminate next? The plus 8. So we eliminate the plus 8 next. So we're going to eliminate this 8 plus 8 by subtracting 8. So we subtract 8 from both sides. So we have 2x minus 8, and the 8 is eliminated from the right hand side. I don't know my left hand from my right hand sometimes. Finally, what do we eliminate? There's only one thing to eliminate. We are going to, I'm just giving you a few seconds more. We eliminate the 5. The 5 that we are multiplying by 5. So we are going to eliminate 5 by division. So we have here f inverse of x, and that will be equal to 2x minus 8 over 5. And it would be bad manners to write an expression like that for an answer. And later on, you will learn that the equal sign is not a two-sided sign. The equal sign is a one-sided, it operates in one direction. So if you change this around and say f inverse of x is equal to 2x minus 8, then that would be the most appropriate thing to do. For one, it will be good manners, and two, leaving it like this does not have the same meaning as this, but we will not discuss that at the moment. So I'm sure that you know about that one. I hope that everyone would have completed the directed numbers homework already. If not, you need to get that done by Sunday. Because when I go on the board on Sunday, there will be no teaching. Right? There will be no teaching for sure. And what I hope is that the students so what I hope also is that all right, so I'll do you more students. All right, so let's continue. My question now is, did anyone see 5 fractions problem? Yes, yeah, I'm going to put 5 every day until they are finished. So I think that we'll have what's going to be now. So today we have, that is Tuesday. So we have Wednesday, Thursday, Friday. So Tuesday, Wednesday, Thursday, Friday, Saturday. So 5 5s, 25. And I think that we have more than 25. So maybe I put sometimes 6 and 7. So I'm putting out the fractions so that if you wish, you may take a look at them. The same kind of problems that we did on Sunday, Yes, I'm putting them up. They are on TikTok. Your favorite. Let's continue. Students, let us look at this function. F of x is equal to 3x minus 5 over 2x plus 7. G, how are you going to find the inverse of that one? No, it's going to take the entire evening. All right. First of all, students, in the same way that you can take a look at any other function, well, not any other, but for the most part, the ones that we have done so far, and write down the inverse of it, we can do the same for this one. And we're going to do that by the what? The inverse of a matrix method. So we have what? The inverse of a matrix method. The inverse of a matrix method. Inverse of a matrix method. Now what do we mean? F inverse of x is, let me write it down here. F inverse of x is equal to, change the position of these two. Don't change the x's though. Don't change the x's. Change the positions of these two and change the signs of these two. Change the positions of these two and change the signs of these two. So when you're through, you should see 7x plus 5 over negative 2x plus 3. Nice. So you see what happens. The 3 and the 7 exchange places and the signs of these two would have changed. And you can write down the inverse of a function just like that. However, we're going to take a look at how that might be done by transposition of formula. So let's go. X goes there is equal to 3 F inverse of x. Do not forget, it's a complete turnaround, and where we see x, we put F inverse of x, and where we see f of x, we put x. So where we see f of x, we put x, and where we see x, we put f inverse of x. We are switching it around. We would very much love to just, where we see f of x, put x, and where we see x, we put f of x. That's what we'd really love to do. But by transposition, when we end up with the expression, it will not be f of x, but it will be the inverse of the function. So it is more appropriate for us to put the inverse right there. And as usual, what do you imagine that we are going to do? We are going to transpose to make f inverse of x the subject of the formula. So I am taking sides now. What we will do first is eliminate this denominator by multiplication. We will eliminate the denominator What's it here, man? If you look outside, they say that you have inactivity. Watch out for me and you TikTok with this inactivity, Joe. Alright, because we're not going to make it more than me. You think we're going to come inside here and work with 3.5 hours without giving the students not even a breather? This TikTok will be like them a slave driver, you know. Alright, let's go. So the first thing that we do is we take the denominator and we multiply by the x there. When doing that, the x is going to multiply by the first one, So the x is going to multiply by the 2f inverse x. So we're going to have what? When you multiply by x, this part to multiply by x, we'll have 2x f inverse x. That's what we'll have. Then we'll take the 7. The 7 will multiply by the x. So plus 7x. And then that plus 7x. And that is equal to 3f inverse x minus 5. What we have done, notice that the numerator remains the same, and then this is multiplied by x. So the 2 f inverse x becomes 2x f inverse x. And then the x is multiplied by the 7, so we get 7x, and that's nice. Now, this is a standard transposition problem. Yes, it's a standard transposition problem. Why? Because it has the proposed subject in both the numerator and denominator. The proposed subject is here and here. So what do? We eliminate the denominator and we find ourselves in similar trouble with 2 occurrences of the proposed subject, and the 2 occurrences are on either side of the equation, which look disastrous. The proposed subject, we have 2 occurrences and they are on opposite side of the equation. So what do? We get them to one side of the equation. So what do we say then? We will write the 7x with the intention to eliminate this. That's what we're going to do. We're going to eliminate this. So we're just holding off on it for a minute, and then this minus 5 here, we're going to eliminate this negative 5 by adding. So we're going to have a positive 5 there. 3f inverse of x will remain the same. It's unchanged. And what do you notice? 2x f inverse x minus, because we have a positive 2x f inverse x, we're going to eliminate that by subtraction. 2x f inverse x. Well, that is somewhat better. Now we have 2 occurrences of the proposed subject, and they are on the same side. What do you think that we are going to do? I heard somebody saying it earlier, so I hope that you mean that we can do it now. So we have what? 7x plus 5 is equal to, how do we get one occurrence? Because we have 2 occurrences now. How do we get one occurrence? We get one occurrence by taking out the factor f inverse of x there. When we take it out from here, it's gone from here, and we have the 3. It's gone from here, and we have minus 2x. Two more steps. Now notice, because of the brackets here, that this f inverse of x is being multiplied by this. So in order to eliminate this, we need to do that by division. 7x plus 5 over 3 minus 2x is equal to f inverse of x. So f inverse of x, I'm looking at your screen now to see if you can see it. Oh no, I'm not seeing it now. Yes, nice. F inverse x is equal to 7x plus 5 over 3 minus 2x. Right here, notice that it is the same thing. It's only that it took a second to do this, and it takes 25 minutes to do this. So when you're doing that, it's a matter of transposition again. But this is a standard transposition problem, and how do we solve that standard problem? We have a fraction, which is more than a fraction. The proposed subject is in the numerator and it is in the denominator. So we multiply. When we multiply, the proposed subject will end up on both sides. When it ends up on both sides, what do? We cause them to be on one side. And after they go on one side, what do? We factorize. And after we factorize, we divide by the large fraction. Sorry, not the large fraction, we divide by the large factor. Right. So that's how we do it. And that's a standard problem. And of course, for those students who this just flew right over your head, it's not going to go over your head when we take a second look at that in January. Now that we have that, the means by which we find the inverse of a function, what else do we do apart from nothing? Right, we're going to take a look at some significance of the inverse of the function. We're going to do that in a few seconds. Let's go. This one. Oh, so it's not this one. All right, so it's that one. All right. What do we say? Now, I'm going to write a theorem, and let's see who can figure out why this is so. Now, there's a theorem that says f of g all inverse of x is equal to g inverse of f inverse of x. F of g all inverse of x is equal to g inverse of f inverse of x. Why is that so? This one is wrong. F of g all inverse of x is not equal to f inverse of g inverse of x. So f of g all inverse of x is not equal to f inverse of g inverse of x. Instead, it is equal to g inverse of f inverse of x. Why? Anyone can tell why? Anyone can tell why? Anyone can tell why? All right. Let's see. No answer so far? All right, no problem. I'll still do it. This is because, yes, this is because when you are doing the inverse of a function, you do not write each step. Don't write the steps in the same order. So if you are doing the inverse of a function, you do the inverse of each step, and you do them in the reverse order. So when you are doing that, you do what? The inverse, and you do that in the reverse order. Now, this is what I will stop at this evening. This function, students used to do it in 1-2 hour session when they were doing face-to-face in the good old days. But over the internet and where we are at today educationally, I understand that we have to be a little bit more patient with what we are doing. Now, we'll do the calculations for this next week, and also we are going to begin a new topic, the equation of a straight line. Notice that in this book, functions, first of all you have functions, then you have what? Quadratic graph. Then you have equation of a straight line, and then you have straight line graph. All right. So, what I'm going to do, I'm not going to do functions and then do quadratic graph. I will do functions and then do equation of a straight line. Reason being is that I want all of your graphical work to follow one after the other. Right, so all of your graphical work will follow one after the other. That's what I want. And I'm very happy to see the younger students making their input inside of this class. Because if you learn something, then when you go to January, it is going to be easier. So I'm delighted to have the younger students who are doing mathematics. Some of you are not doing mathematics at all this year. Some are doing it next 2 years, next year, and so on. But that's fine. But the students, sir, will you do this again Thursday? No, because this is the accelerated class for the January exam. Thursday is the regular pace class, and that is going to be the next topic in this book. So on Thursday is the next topic in this book, which is what? Indices. And we're going to finish that one on Thursday. Yes, we're going to finish indices on Thursday. Only the homework will be left when we are through with it. Yes. So when we are through with indices, only the homework will be left on Thursday. But we will do this again in January. So everything that I'm doing in this book on a Tuesday, everything that I'm doing on a Tuesday, will be done in January, but not necessarily on a Tuesday, because maybe in January the Tuesday class will be eliminated. Right? So maybe in January Tuesday class is eliminated, so you'll do it on a Tuesday or Monday, Tuesday, in the Monday, Thursday class. Right, so we'll do the calculations involving the functions next week. And for now, I'm saying that, of course, you know, we have to give respect where respect is due. I'm delighted to have the students here. I'm delighted to have you share the live. We have new individuals who you introduced, and they are coming in and they are following me on TikTok. Yesterday, I had over 100 new followers on TikTok. That's good. That means, you know, the word is spreading and individuals can come on and learn mathematics, maybe learn a single topic, maybe learn to manipulate some digits, maybe learn some fractions, learn to manipulate directed numbers, if nothing else. But my entire intention is to do something good for everyone. I see here that although from this one, how many followers do we have? Maybe 24 new followers going there, but here we have about 44. You know, and we still have just respond to, oh, sorry about that. All right, so we have some students following again, you know, every day. We have a second rose. Thank you for the beautiful rose. And what's this next one? And music play. I don't know what that is. I will figure out what those are in a minute. But the part that I need to figure out, I think that I figured that out for the most part, how to go on TikTok and to get the students to come in and participate in the class and the rest of it. So, for students who are new, because students are all, we're going to always have new students. I'm taking up the resources. Just give me a few seconds. Now, students, we have the mathematics resources. And for the CSEC program, the resources are in 3 parts. We have the instructional manuals. We have the instructional manuals. We have algebra. Functions part 1. Functions part 2. We have computations part 1. Algebra contains the topic in directed numbers, indices, basic algebraic expression, factorization. Then we have transposition of formulae, solution of linear equations, solution of quadratic equations, solution of simultaneous equations, and solution of simultaneous equations, of which one is linear and the other quadratic. Of course, this is your regular textbook format. It's not a textbook, students. I don't have textbooks. It's a regular textbook format where you would have your, in terms of what is written, how it is written, you'll have it there. Everything typed nice and explained nicely, and the illustrations are there, the examples are there, everything that needs to be there is there. Then, of course, when you go to the answer section, it is written with the hand. Right? It is written with the hand. So when you go for the answer, you do not just see that the answer is 5 or 15, you see how we arrive at the answer. Everything is worked out for you nicely. And that is what we have for our instructional manuals. Of course, this is functions. So if you are looking at functions, you expect to see completed tables. You expect to see graphs, although I don't see any yet. But you expect to see graphs. It depends on where I am at. Right, so if you go, you should see everything done with the hand. I don't see any graph yet. There you are. So you have the graphs. Everything is done. So what cost, what's the cost for, okay, the cost for everything. Of course, for the CXC, CSEC students, you know that we have 14 books. And our 14 books, are the total cost is $23,500 for the 14 of them. And those are your instructional manuals. Then students, you have your tutorials. I'm just going to take up one. You have tutorial 1 and you have tutorial 2. So we have tutorial 1 and tutorial 2. This is tutorial 2. This one is the question book, this one is the answer book. For this tutorial 2, you have what? 130 pages of answers in this one. But the other one, tutorial 1, I think you have 160 pages of answers. You know what I'm going to do? I'm going to put it to 24,000 because people always forget the 500 at the end. It's 23,500. It's 23,500. In the long run, I might get individuals who sponsor students the books because it might be costly for some students. But do not forget that even if the books are somewhat costly, because they come at a cost, they come at a price, that when you purchase the books and you're in the class, you will not even have to pay a cent for the entire school year. That is good for you. So we have tutorial 2, I'm just demonstrating here. And of course, we have tutorial 1, but I'm not demonstrating it. What's a tutorial? For every topic that I teach in the class, we have questions. So it is arranged according to the topics. Now, not all of the topics are here. I guess most of them are here, or all of them are here. So we start off with fractions. Then we go to decimals. Then we go to substitution, transposition, simplifying expression, indices, ratios and proportions, factorization, linear equations. Any topic that we have for CXE, we have that in this book. We do not have every topic in tutorial 1 because the 2 books were designed to complement each other. Tutorial 1 covers the course and it is intense. It is very intense. Tutorial 2, let me say that, tutorial 1 covers the core of the course and it is very intense. Tutorial 2 covers the entire course and it is not so intense. No, it is not so intense. So we have those. They are given in topics and we use them generally on a Sunday evening when we are solving problems. Now, in addition to the tutorials, you're welcome. You are most welcome. Now, this one is one of your final examination preparation resource book. Let me look over here and see what's going on. That's nice, man. But let me go back over here and just do this. Students, you know how I operate. Notice that you have a tutorial 1 and you have a tutorial 2. The 2 books complement each other. Tutorial 1 covers the core and is intense. Tutorial 2 covers the entire course and it is not intense. The books complement each other. These books, of course, you know, you'll imagine that they also complement each other. This one is your paper 1 practice and this one is your paper 2 solution. The examination is in mainly 2 papers. So students, this is your key. You cannot fail when you have this book. But you will not get a distinction if you do not have this book also. So this book guarantees that you will pass. While this book places you in the position for you to get a distinction. Okay. I see this, couldn't do this back again another time. Well, I think that I've said it about 150 times that what we are doing today will be done in January. But this Tuesday class is a class that accelerates the program for students who are doing the exam in January. So anything that I teach on a Tuesday will be taught again. Nice. So those are the books that you have. So we have the 7 instructional manuals over there. We have your tutorials, 2. So we have tutorial 1 and tutorial 2. So that is 4 pieces because they are divided into 2 books, each divided into 2 books. And then we have final examination preparation resources. Yes, so we have 3 types. Where can the books be sourced? I have all of them. The Ministry of Education should have all of them because they were advised to take the books many years ago. But because of politics, they don't want it. They have too much nepotism and friend business in the Ministry of Education. I'm not going to look on them again. I'm not going to ask them nothing again. So I have all of the books. And the person who is asking, where can the books be sourced? Which parish are you in? Which parish are you in? Manchester. All right, you see, for Manchester, students from Manchester and even teachers from Manchester purchase books from us all the time. So the Manchester students, they do Knutsford. So I send them through Knutsford Express to Manchester. Yeah, send them through. So they are sourced in my office in Montego Bay, and I will send them through Knutsford Express to Mandeville. You're welcome. Okay, so of course, you know, the time has come for me to say thank you to all of my students. Thank you for sharing the live. Thank you for inviting others. Thank you for your gifts. What else do I need to say? Thank you. Thank you for your presence. Thank you for your cooperation. Thank you for your feedback. I say thank you for everything. And as I say goodbye, have a peaceful and restful night. And we will see each other again on Thursday. And I expect the Thursday class to be bigger and students to be more enthusiastic and students to be giving more answers and so on. So for this evening, when you see the hands go up, you know that's the end of it. So it is goodbye until Thursday evening. You're welcome.